In designing layouts and animations with Flutter course, you can expect to learn the different layouts techniques in Flutter, including responsiveness and working with images, and enhancing user experience by adding animations. Without further ado, let's get started. I should mention this course and all codes are all tested and will work with Flutter 3. First, let's start understanding widgets and layout principles in Flutter. Widgets are the basic building blocks of a Flutter app's user interface. Each widget is an immutable declaration of part of the user interface. But what does this mean? Let's analyze. Here's an example of a mobile app, which basically the entire screen is a page. And an app can consist of several pages, which you can navigate from one page to another. A page consists of several smaller pieces that builds this page. These single units are all widgets. The images, icons, and the text that you see in a Flutter apps are all widgets. In Flutter, almost everything is a widget. Even layout models are widgets. Okay, let's see what do we mean with layout models. Looking again in our page, we can see that there are a few sections: the action bar, top categories, titles, course sections, another title section with highlights, the course paths, and the button navigation bar. This page actually looks like a column. A column widget is a fundamental layout widget used to arrange content vertically and can have several children. Let's take a look at one of the children. This section is also a column, but it looks like that the children seems to look like a row. But what is a row? A row is a fundamental layout widget used to arrange content horizontally. In this case, we have an image, column, and icon. Let's take a look at the column child in the middle. We can break down the children of this column, which has 2 widgets and 2 rows. What are we doing here? So take a moment. We're breaking down the layout into smaller pieces until we reach to the smallest widget that doesn't have any children and displays something, whether a text or an image or an icon. That's how we are drafting or creating our layouts. There's one more thing though. In this user interface, there is a component of UI that has text with background and some padding around the text. This can be achieved in Flutter by using container widget. You can think of a container as an element that can shape in different ways and sizes. If you are a web developer, you are literally compare container with div, where you can style in it in any way that you would like. This widget or similar widgets accept one child. All right, you may ask now why all of these matters. Because of composition. Widget composition is the process of assembling multiple widgets to construct the user interface. This involves building complex widgets by combining simpler individual widgets. That's how you build layout. Though I need to mention one more thing. There are 2 types of layout widgets. One that takes a single child, for example, container, or the ones that takes a list of widgets or children, for example, rows and columns. We already have seen that as an example, but let's see that in code. Here's a container widget with single child, which is a text widget. And here is a column widget with 3 children of text, column, and row widgets. All right, let's go back to the page again. So let's take a moment and memorize this page, and let's see what will happen when we compose these widgets. Let's imagine we start with a column, which may have 3 children. The container may have one child, which is a text widget, and a column may have two children. A row, which is already a children or a child of a column, may have three children, and a column in this case may also have three children. A row down these three will have three widgets children icon. Okay, what do you see right now? I bet you are now thinking of a tree, and you are absolutely right. This is how Flutter creates widget tree, where Flutter internally can keep track of each widget and their parents for things such as a state update, performance optimization, widget lifecycle, and so on. So this widget tree also sets the relationship between parents and child. All right, so there is one more thing that I would like to share with you, where now we are thinking about parents and child and children's. So there is a golden rule in building layouts in Flutter, and that is constraints go down, sizes go up, parent sets position. What does this mean? Let's take a look at that. Constraints go down means the parent container sends size limits, constraints, to its children, telling them the smallest and largest sizes they can be. Sizes go up means each child decides its own size within the given constraints and sends this size back to the parent. Parent sets position meaning finally the parent places each child in its layout based on the sizes it received. This is very important rule when it comes to working with widgets and building layouts in Flutter. You will see some example in this module that I'm going to create for you. When you start to build an app with Flutter, essentially you start with a root widget, which enforces the structure and styles. When setting up the root widget of your Flutter app, you will have three main options. Material app for Android style apps, Cupertino for iOS style, and a third option for non-material apps, which allows for more customized approaches that don't adhere strictly to material or Cupertino styles. The choice you make here will define the overall look and feel of your application. Though material is the go-to choice for building apps that follow material design principles and is the most comprehensive and complete, as well as the most flexible widgets that you know that comes along with it. Therefore, I recommend you to start with Material app. Don't worry, you will see an example shortly. In this clip, stay with me. In a Material app, the scaffold widget is a key component. It provides a basic structure for the visual interface. The scaffold ensures that your app has a consistent layout. Let's see why scaffold is an important widget. Breaking down the scaffold widget, here in this case, we will have three main sections. The app bar at the top, the body that the most of your content is displayed, and the button navigation bar for easy navigation between different pages. All right, enough theory. Let's just see everything in action. Here is an empty Flutter project that is return a container. And as you can see, my simulator only showing a black screen. I'm going to use Cupertino app as my root widget in this case. And I will also add a home page, which is going to a scaffold, which I'm going to use Cupertino page scaffold, and also showing a center text widget as hello world. And as you can see, the look and feel is similar to iOS. We can modify a bit to see what properties we have. I can go to the Cupertino page scaffold, and you see that I have navigation bar and background color. I can change my navigation bar. And to do that, I need to pass Cupertino navigation bar widget. There you go. Now I have a navigation bar. I'm going to do a few more changes. Let's go to Cupertino app. You see that you have multiple properties. We used homepage already. You can change the theming, you have routing system, and so on and so forth. So in this case, we're going to change a bit of theme data. To do that, I need to pass the Cupertino theme data. I can change the primary color or the nav bar color, and I can even change the brightness here to make it light mode or maybe dark mode. That's where you need the root widget, Cupertino. And as you can see, when I change the brightness, everything has changed without you dealing with anything here. So the Cupertino page scaffold, as well as the Cupertino app root widget, is going to enforce the style for the entire app. All right, that's it. Let's go and test it out with Material app. First, let me just remove the theme. Then I change the Cupertino app to Material app. And I change the Cupertino page scaffold to scaffold. And as you can see, there is a few of the changes here. We don't have navigation bar on a scaffold material. I'm going to remove it. And there is no child. If I take a look at the scaffold, there are multiple parameters here that you can use. I encourage you to test out everything. But for now, I'm going to go and use 3 of these options. I changed the child to body. And we're back to what we have here. But in this case, it's going to be a material app. I'm going to add the app bar. And I will make sure that I pass a title. I will also define my button navigation bar. The item property is required, so you need to pass an array of the icons and the buttons, which is going to use button navigation bar item. And there you go. Now we have a button navigation bar, an app bar, as well as a text. And as you can see, the design looks and feels very much enforced, and you have done nothing here. So you can even change the theming in the material root app. So I can have a theme, which I can pass my theme data. You can change the primary swatch with from blue to anything else that you want. For example, you can change the app bar theme color. You can also pass the dark theme to your material design and pass the color that you like. You can even decide which theme should be the default with theme mode. It could be system, light, or dark. And as you can see, everything is going to be enforced. That's where the beauty of the Material app is. And this is not the only thing you can do. If you can go to Material app, there are a lot of properties that you probably want to take a look. There's also a couple of helpers here. For example, there is a little debug icon in the simulator. You can even remove that. There are many things that you can do here. And as you can see, my app now feels looking like material design applications. So I can prove that. For example, if I go to my center, I can prove that. So let's go ahead and remove the text and replace it with a switch. And I'm going to change the value to true and a callback of unchanged to print. And if you see now, this toggle, this switch is very looking like a material app, even though we are on iOS. Though switch has another factory that you can use if you say adaptive, then it will look like an iPhone one, even though you are in material root application. But to prove this one only, I'm just going to go and return to my Cupertino app again. And then I will change my text to Cupertino switch with the value of true and then a callback of print. And as you can see, that is going to be immediately looking like an iOS. And that's where I said the style is going to be enforced by the root widget. All right, there's one more thing I want to say very quickly before we end, and that is when you are using a widget that is belonging to a material app, or the other way, in another root widget. Let's say, for example, if I just change this switch, Cupertino switch, to a switch, and that's where you get an error because this is belonging to a material root widget, which does not exist. That's why you need to be careful. If you've seen this error, you need to make sure you need to properly use widgets that are belonging to the root widget. I encourage you to use material app and play around with a lot of properties that you've seen. One of the fundamental widgets of any Flutter application that is displaying text is the text widget. There are 3 different text widgets in Flutter that you can use. The basic text widget for simple text, rich text for more with complex, style text, and default text style for applying a consistent text style across multiple widgets, which they don't have an explicit style. Each of these options give you flexibility in how you present textual information in your application. The text and rich text are the more 2 important widgets. Let's quickly see how you can use them before seeing a demo. Let's start with the basic use of the text widget. Here we simply display a string of a text, hello Flutter, with the default styling provided by Flutter, or in fact by the root widget, which is going to be material app and your scaffold widget. This is the simplest way to add a text to your app. Now, let's take a step further by customizing the text appearance. In this example, we're using the text style property to change the color of the text to blue. This allows you to easily adjust the visual presentation of your text widgets. While using a style is great, you may want to apply one style to several widgets and make your UI consistent. Here we are applying a theme-based style to our text widget. By using theme, we ensure that the text follows the app's overall theme, which is useful for maintaining consistency across the user interface. You can modify the theme from the root widget. For example, the material app will have a default theme where you can modify or customize. You will shortly see that in the demo in this clip. Sometimes the default theme doesn't feel the need. Then you need further customizing the text. You can use copy with method to modify specific properties of a text style derived from the application's theme. All right, so when you need to display text with multiple styles, that's where the rich text widget comes into play. In this example, we're using text span to apply different styles to proportion of the text. Here, the word bold is displayed in bold, demonstrating flexibility of rich text for the complex text formatting. All right, enough theory. Let's actually now go ahead and see all of them in action in a demo. Here's a simple Flutter application that uses Material app as the root widget and the scaffold for scaffolding the page. And I will use Center widget to center my text. And in this case, I just have an empty container and the app does nothing. Simplest way to show a text is just to use the text widget. In the text widget, you can change the style by passing the text style constructor to the style parameters. For example, here, I'm going to change the font size to 24. Or I can even change the color to green. This is not going to be scalable. So the best is if you can pass the style from the theme data. On the theme data, you will have access to the text theme and you can select what text style you want to use. For example, I'm going to use the headline large in this case. The good thing about this is that now every time I change the headline large on the theme data, let's say to do that, and then you need to pass your new theme data. So once you do that, then this text is going to inherit the style from the theme data. All right, let's now see how you can create rich text. To create a rich text, actually, you can use the rich text widget. So the rich text widget is going to have a property of text where you need to pass a text span. So let me just quickly write this code. And here we go. So you're going to have the text span, and then the text span is going to have a text where you pass the first text, and then you will also have a children. Well, the children is going to be a list of text span again. So here is a quick example that I've done. Let's save and refresh. As you can see, you don't see anything on this screen. It's just because the default text style is now actually gonna have white color for the text. Let me just quickly change the style here and read it from theme data. There you go. Let me change it to headline large. And now it's bigger. And as you can see right now, my second word is bold because I'm passing the style through this. I can even change the style to read it from theme data, in fact. Let's do that quickly. This time, I'm going to use copy with to pass the font weight to the font weight that I want, because the headline in this case does not have a font weight of bold. So you see an error here is just because the children in this case cannot be a const. So I just need to remove the const and move it to where it needs to be. There's one more error here, as you can see, and that's because we're calling copy with on headline large, where the headline large can be actually null. So I just need to pass the question mark to fix the nullable problem. And there you go. Now I can even change the color. And as you can see, you now have a rich text in your Flutter application. We have seen column and row widgets already. Let's quickly review more in details. To arrange widgets vertically, Flutter uses column widget. Each child widget within the column is stacked one on top of the other along the main axis. All right, that's new. Let's take a look at the main axis here. The cross axis, meanwhile, determines how the widgets are aligned horizontally within the column. On the other hand, the row widget arranges its children horizontally along the main axis. In this example, the image, column, and icon widgets are laid out side by side. The cross axis in this case dictates the vertical alignment of these widgets. All right, as always, nothing will beat a demo. Let's see all of this in action. All right, here is my clean project again, just having a container in my material app and a scaffold widget. First, we're going to use column widget to create a column. So let's do that quickly. So the column widget is going to have a children property where it's going to accept a list of columns. So I'm going to quickly create columns with containers where the container is going to have a width, a height, and a color, and potentially also a child with a center text of number, just to get an idea what we're doing. And as you can see, my container does not position well because it goes over to the safe area. So I'm going to wrap my column with a safe area widget where it will make sure that we are not going over the safe area in the phone. Fantastic. Let's go and create 3 more containers. I'm just going to copy the first one and paste 3 times. All right, for the second one, I'm going to remove the widths. And then I'm going to change the color to green. And I will repeat that for the third and fourth one. That's how we are creating our column with children. All right, I'm going to show you a tip right now where you can inspect your widget. Either you're using VS Code or you're using IntelliJ or Android Studio, you're going to have access to Flutter DevTools. Open that and then open the widget inspector. So in the widget tree, we talked about it right now. Let's take a look at that quickly. You can see that right now. Let's take a look at the widget tree first. You can see that my column is going to have 4 children here. And my container is going to have another child, which is center. And the center is going to have a text widget. So this is the way that we are creating the widget tree. We talked about it already. So what I'm going to do right now, I'm going to select the column in this case. And as you can see, the column is actually taking up the entire space. So, but why not all of the containers are going all the way down? All right, that's a good question. Let's take a look at how you can fix that. That's where you have the main axis alignments. The main axis alignment may have multiple alignments that you can use. For example, a space between, or center, and space around, space evenly, and a start. The reason now you've seen in the beginning everything in the start, it was because the main axis alignment in column is a start. Let's keep a start for now. Though there is one thing that you can do to control these childrens, and you remember probably the golden rule, right? So that the constraints goes down. So we're going to go on the second container right now, and I'm going to wrap it with another widget that's called flexible. The flexible widget by itself doesn't do anything except that you can pass the flex number. Let's say, if I say now, all of these right now are going to have a flex 1, but if I pass that to number 2, it is going to take up more space. But why this doesn't do anything right now? It's just because of the fit property. The fit property, it will have 2 options, either a loose property, which means technically, well, it can take up the space as much as possible, but not really tightly. So that's actually the default. I can change it to tight, and now as you can see, well, so it's gonna work better. There's another alternative to flexible as well to control this, and that's gonna be expanded widget, where the expanded widget does not need fit because expanded gonna have fit by default tight. So that's gonna be the same thing. And there's one more thing I wanna explain here, and that's gonna be the cross axis. So the cross-axis alignment at the moment is going to be center, so the default. But then I can change it to, for example, end, start, or stretch. Well, let's see what's happened to stretch. Voila. The containers that did not have widths, they actually stretch to fill the entire cross-axis. And that's because now my parent, the column, is passing down the constraint to say, hey, you need to fill up everything. All right, great. Let's now go ahead and see the row. All right, I'm back to my main project again. Let's go ahead and add row. I'm just going to paste the same container that we used for the column. There you go. I'm going to have 1 child right now. So let's go ahead and repeat that. Make sure we are changing the text and the colors. There you go. Now I have a row here. All right, there's one more thing I want to do, and I'm just going to remove the height of the second and the third one. All right, that's good. Now I have my row. So the first thing we're going to try is the main axis. So the main axis here in this case, going to be similar, but it's going to act in the row. So we're going to have center and space around, space between, space evenly, and a start. And the same thing we're going to do for cross-axis. So we're going to have the cross-axis center and start and a stretch. All right, that's good. So let's go for the start as the default. And let's try out the expanded and flexible. So I'm going to try expanded in this case. We now know the difference between expanded and flexible. So I'm just going to go and give it a flex 2. And the same thing is going to happen, but in a row. And that's how you're dealing with row and column. Let's now imagine you want to compose your layout. So you can go ahead and have a column as a child of the second one instead of a text. Let's do that quickly. And maybe one of the children of this column can be a row again. And this goes on and on until you're creating your UI. But the principles are going to remain the same. And that's the way you are composing your UI layout in Flutter with column and row. Layout composition in Flutter involves using widgets to arrange and organize your UI. To create more complex layouts, we need to use advanced positioning techniques. Flutter provides a wealth of built-in widgets that makes designing flexible, responsive layouts much simpler. To create advanced layout, we need to master positioning techniques. In Flutter, stack, padding, and containers are your go-to tools. Let's begin with stack widget, which allows you to layer widgets on top of each other. This is perfect for scenarios where you need overlapping elements. You can position widgets on top of each other and adjust their alignments and size. For example, in a card design, you might want to place an icon on top of an image. When working with the stack, the position widget is key for controlling where each child element sits. It gives you fine-grained control over the position of each widget. You can place elements using the top, bottom, left, and right properties. Spacing between widgets is important for making your UI more readable and visually appealing. Flutter's padding widget helps you add space around and inside a widget, making sure elements don't feel cramped. The container widget is one of the most versatile widgets in Flutter. It allows you to customize its look and feel. You can use a box decoration property by which you can add background colors, borders, round corners, shadows, and more. All right, now it's time for a demo. Let's see a quick demo. All right, here's a simple project. Let's start by wrapping the text widget with a container widget. I just need to remove the const and add it back to the text. So now my container will have decoration, which imagine now I'm going to have a border around my text. And here is adding a box decoration where you can change the border. And this is going to add a border around my text. Now I can go ahead and play around with other properties as well. For example, if I want to make a gradient background for this, I can simply do that. So the problem is that right now my text is very close to the border because I need a padding. I can do it in two different ways. I can either go to the container and add a padding, or I can wrap my text widget with a padding widget. So as you can see, the padding requires edge insets. So I can use either all, which means all around, or I can specify with other options, for example, from left, top, right, bottom, only from one I mentioned. For example, if you just want to say from each side, how much? For example, if you want to just say from top. Let's now do a little bit fun here and add a background to my text style as colors white. So now let's go back to my padding. And this time, if I put it at 0, then the gradient, the background for container is not visible anymore. And if I add maybe symmetric from vertical and horizontal, then I'm going to have some padding between these two widgets. Let's quickly define a stack widget. Then in this case, I'm going to have a children, and then I'm going to define 3 different containers. And each of these containers is going to have a different size and a different color. And as you can see now, they are overlaying on top of each other, which is the red in the below and the rest on top of that. All the children start on the top left side, but you can control that with alignment. You can change it to center or any other properties that works for you. For example, maybe you want bottom right. You can now play around with position widget. Go ahead and wrap the second widget with positioned widget. And now you can define where this position can reside. For example, you can define from top to bottom and so on and so forth. Another interesting thing you can do here is that you can have the position as minus, which means it's not going to be in the view. But how can you fix that is by clip behavior property. By default, you're going to have clip hard edge, which means if it's outside of this, it's not going to be shown. But you can also set it to none, where in this case, you will see the overflow of your widget. Let's put it minus 40 and minus 50. Looks good. All right, let's see actually a real example here. So I'm going to define a sized box, which is going to have a stack as the child. Then I'm going to quickly define a container with a background of white and another container with some padding, alignment, and a decoration with a gradient background. Then I will make sure that this container is going to have a child, which is going to be a text widget. And voila, this is very familiar, right? So maybe you have a photo that you're going to have a gradient from top or from bottom, and you will have some text on that to be visible. The possibilities right now is endless. When building apps with lots of content, managing space efficiently becomes crucial. Flutter provides several scrolling widgets like list view and grid view to help organize content dynamically. These widgets ensure that your app handles large sets of data while maintaining performance and responsiveness. Let's start with list view. This widget allows for vertical or horizontal scrolling of multiple items. Whether you are displaying a simple list of text or complex custom widgets, List View automatically handles the scrolling, making it ideal for content-heavy apps. At its simplest, you can just pass a list of children and it handles the rest. Often, you'll need to display a large number of items dynamically. This is where List View Builder shines. It efficiently creates items as they scroll into view, helping to conserve memory and improve performance. When dealing with items that needs to be displayed in a grid, like photos or product listings, Grid View is the go-to widget. Both Grid View and List View can scroll in two directions, horizontally and vertically. The main and cross axes are defined according to horizontal or vertical scrolling in the Grid View or List View. The simplest way to use Grid View is using the count and pathing how many items you want in the cross axis. When you have a large number of items dynamically, you can use a builder function to create and populate grid items on demand as the user scrolls, which makes it suitable for displaying large collections of data. Note that Grid Delegate and Item Builders are required. Grid Delegate is a delegate that controls the layouts of children within the grid view. All right, I understand. Let's actually see them in a demo. All right, here's an example. Let's go ahead and create a list view. For its children, I'm going to write a loop where it's going to generate containers with some size of a height and a color and a text. This is going to generate a list that is scrollable right now. There is a couple of properties that I would like to show you. First is the padding. You can actually set a padding into this list view. For example, here is a padding of 18 from all different edges. This list view now is showing 15 items. And as you can see, it's bouncing. you can change this physics. For example, if I change to bouncing physics, this is not going to work anymore. It is because you need to have more item that goes off the screen. For example, if I change it to 25, now this time I'm going to have a bounce effect at the bottom. So in this case, if you want to keep the bouncing always happening, then you can use always a scrollable scroll physics. Then in this case, you're going to have the default behavior of the platform. Let me now again change to 25, and this time I want to add cache extend to 20. This property describes how many pixels the cache area extends before the leading edge and after the trailing edge of the viewport. Like how many of items can be cached off the screen or in the screen. Like when I scroll down, now entry number 2 and above are off the screen, and the other way around, entry number 16 and after that are off the screen. Another thing that I want to show you is add automatic keep alive to false. What happens is that whenever some widget goes off the screen and if there is any state, it will be garbage collected. But if you don't want to do that and you want to keep the states alive, then you can actually set this to false to make sure that you are keeping all the states alive. Otherwise, it will be automatically garbage collected. Next one is the scroll direction. So you can actually change the direction of a scroll from horizontal to vertical. And that's what you can do as well. You can actually change the scroll direction from horizontal to vertical, which the vertical is default. All right, this example just shows a set of widget that you have it as a fixed number. But what if you have a dynamic content? For example, imagine you are receiving a list of data from your database. Well, in this case, I'm going to mock that with entries. Then we need to do a quick refactoring here. So I'm going to change this to a builder. And I'm going to go and instead of children, replace that with a builder, item builder, which that is going to return my container. All right, one more thing I need to do here. I need to also pass the item counts, which in this case is entries.lengths. So now this is going to work as it should. To prove, I'm going to change it to 45, refresh, and now I have all of my items. And one more thing, what if you want to just have a separator between each of these items right now? And that's where you can change the builder to separated. Now you need another required property, which is separated builder, which in this case, I'm going to add a divider with a height of 1. And there you go. I can even do one more thing, and I can probably add a padding. All right, that's great. But let's now remove the list view and start adding a grid view. The simplest way is a grid view count, where you can have a children property, and you can, of course, use the container that you used. And there is one required argument, which is cross-axis count. If I put it 1, let me just have a for loop here. This is going to iterate over the list of entries that we have. And if I put it 1, that looks like a list view. But if I put the cross-axis to 2 or 4, that looks much better. You have other properties here too. For example, you can change main axis spaces if you need some spaces there, or cross-axis spaces if you need it there, or even you want to have a padding around all of this. This is looking pretty good right now. You can also control your physics, as we just explained in list view, and even the properties such as add automatic keep alives, and a scroll direction to do it either vertical or horizontal. This is probably good when you have a fixed item, you know the numbers, but if you don't know, like for example, a dynamic data, you can change it to a builder where it's more optimized for that. So what you can do, you can change the count to builder, and then instead of a children, you're going to have item builder function. Let me this time actually use a Flutter logo. The grid view builder needs another property which is required, and that is grid delegate. The grid delegate, you have two options. Either you can do a silver grid delegate with fixed cross-axis count, which in this case, it creates a layout with a fixed number of tiles in the cross-axis. Let me change it to vertical. There you go. Or you can change it to silver grid max cross-axis extent, which in this case, you need to specify which, or you can use silver grid delegate with max cross-axis extend, which is going to create grid layouts with tiles that each have a maximum cross-axis extent. So in this case, you need to define the max cross extend. I'm going to give it a 200 here. All right, let me go back to the previous one, the fixed cross-axis count, and put it as 4 and a spacing, and this is gonna look nice. And that's about grid view. Images play a crucial role in most applications, from icons to a full screen background. In Flutter, you can easily load and display images from both local assets and the internet. Let's start with local images. To use images stored in your local project, you first need to add them to your PubSpec YAML file. Flutter allows you to bundle assets like images into your app, making them easily accessible from the code. Once you have added image to your PubSpec file, you can display it using Image Assets widget. This widget is designed to load local assets efficiently. Next, let's talk about loading images from the internet. Flutter makes it easy to load remote images using the image.network widget. This widget fetches the images from a URL and displays it directly into your application. Often, it may take time that a remote image to be loaded. To improve the user experience when loading network images, you can use Fade-in Image widget. This widget provides a smooth fade-in effect while the image is loading, and it allows you to display a placeholder until the image has fully loaded. Loading images from the internet doesn't always go as planned. Network issues or incorrect URLs can lead to errors. To handle these scenarios gracefully, you can add the error builder parameter to the image network widget, which displays a fallback widget when loading fails. And last but not least, when dealing with network images, caching becomes important for both performance and user experience. The cached network image package allows you to cache images locally so they don't have to be fetched again on subsequent loads, improving the app's responsiveness. Well, you need to add this package to your PubSpec YAML file before you use it. All right, let's actually see all of these techniques in a demo. All right, let's start with local images. I'm going to go and create an asset folder, and under that, and images to keep all of my local images under this folder. I'm going to drag and drop one image to this folder, and that's going to be dash.png. First, I need to actually reference that in my PubSpec YAML file. I'm going to have an assets property under Flutter, and then I'm going to define the path to my image. You can always pass a folder with all of the images under and then all the subfolders as well. But I'm going to reference that right now, my only image. Next, I'm going to go to my project and then I'm going to use center. And this time, I'm going to load my image locally with image widget. There are two ways that I can do. So as I said in the slides, maybe I can just use the constructor, which in this case, I can use assets, files to load any files that you are loading from your library, memory, if you have any memory image stored and then you want to load, and a network. So if I want to use the asset, I can use the assets. Let me also show you another tip. You can actually also use the image widget itself, where in this case, you need to pass an image with a class of assets image while passing the assets. So in this case, I can just go ahead and say, here is my assets path, and it's going to show it. This is going to be same as image.assets. Let's try that. Let me just remove this. So this time I'm going to go on image and assets, and I'm just going to pass my assets, images, and dash.png. This cannot be a const. I'm going to remove, and there you go. Here is my local assets. There are several property here that you can play around with. For example, you can define width and height, or you can also define the box width, which means how you want this image to be covered in a box. Like you want to have it as a cover in this case, or more of a contain, field, or maybe scale down and cover. If I now just change the asset to network, then in this case, I need to pass a URL. Now I can actually change it to fade in image, where this time I need to use a constructor of assets network. And I make sure that I'm passing my placeholder, which is gonna be the reference to any local assets and my network image. This time, it's gonna show the local asset, and then once it's loaded, then my network asset. That's good, but what if this is gonna fail? That's where I can have either image error builder or even placeholder error builder in case your local asset fails. Let me keep my image error builder in this case, where in this case, I'm just gonna show maybe error icon. Let's deliberately change this, and there you go. Now you see an error. And next, what if I want to cache this and every time I come to this page, I don't need to load this anymore? And that's where we need to go back to our pubspec YAML file. And then we need to add a new dependencies, which is gonna be cached network image. Make sure you're running Flutter pub-get to get the package. Then this time, I'm gonna change this with cache network image and then passing my URL. And when I refresh, I actually see an error, missing plugin exception. And that's because I need to stop my project and build it again in order to leverage the plugin that is installed in my Flutter application. And let's do that. And voila, when it's loading, now you see the image. And if I refresh right now, you see the loading is gonna be much faster because it's cached. There's also other properties here. For example, you can have placeholder or you can have error widget to handle any errors or placeholder. Let's say now I'm adding a placeholder as loading and then an icon for in case there is a problem. There are actually more that you can do with cache network image. I encourage you to check out the package documentation on pub.dev. In today's world, users access apps on a variety of devices with different screen sizes, from phones to tablets and even desktops. That's where responsive design comes into play. Let's start with the fundamentals. Fluid grids are a key element in responsive designs. Rather than using fixed dimensions for your UI components, fluid grids allow layouts elements to grow or shrink proportionally as the screen size changes. This flexibility ensures that your app looks good on small screens like smartphones, as well as on larger screens like tablets or desktops. Breakpoints define a specific screen width ranges where your app's layout changes. For example, you might want a single column layout on a small screen, but a multi-column layout on a larger screens. Flutter doesn't enforce breakpoints by default, but you can easily implement them using conditions based on screen widths. There are two main approaches to measuring screen spaces in Flutter. Either you can use media query and get access to the size of a screen, or you can use Layout Builder. The choice between them depends on whether you want the size of the entire app window, which media query is going to be very useful, or a more local widget-based measurement, which Layout Builder plays a role. You will learn more about this in the upcoming videos, and you will see that in action. Let's actually quickly see how it looks like. Flutter's media query widget enables you access the screen size information and use it to create adaptive layouts. On the other hand, with Layout Builder, you can use the size of a specific widget's layout constraints which allows for more localized and precise sizing. Now, let's move on to the next videos for demos, where we will put these responsive design principles into practice. Let's talk about media query first. Media query establishes a subtree in which media queries resolves to the given data. For example, you have size, orientation, and so on. In other words, media query is always there, just access it by using media query of and get the device data. For performance reason and being more efficient, it is recommended to use methods such as size of when you want access to particular data in media query. With size of, you can get the screen size information, you can check the device orientation. With orientation of, you can determine if the user has modified the default font size. With text scale of, you can also access lower level accessibility information such as animation preferences or the screen contrast by using disable animations of or platform brightness of. And there are more. All right, let's actually see all of this in a quick demo. All right, here is my simple application. Let's define a media query variable here where we're going to have access to media query of. You will get access to many information. You can actually check one by one. Let's actually get the size of the screen. And in this case, I'm going to check what is the width. And I'm going to go and load it here dynamically. And of course, this cannot be a const anymore. And voila, I now have my widths on the screen. Let me actually change the size. And if I now rotate my application, that's going to change to another size. And that's how you get access to the widths. Let's actually optimize that by getting access to size of. In this case, I will have the same access to the widths. That's not going to change. But then instead of having access to all of the information that is not necessary, for me, it wasn't necessary, then I can get access to what it was necessary. So it's more optimized and performant. Let's actually repeat one of our list view that we've done in the previous module. Now, based on this media query widths, I can actually change, let me just actually change the media query variable to width, and that's based on the screen widths. And now I can actually change the scroll direction based on screen widths. Let's say if the screen size is more than 600, so if I now rotate it, then it's gonna change. All right, let's actually go back. There you go. And this time, I'm going to also actually get the orientation using media query orientation of. And this time, instead of widths, I'd say if the orientation, I see I had a spelling error as well. Let's actually fix that. I'd say if the orientation is landscape, then show horizontal. Otherwise, vertical. Let's give it a try. There you go. And there you go. And that's it. You can even mix and match these together. You can say if the widths and the orientation are something, or even way more. And that's it. You have way more information about the device and the setting and that you can get from media query and mix and match them and make your layout adaptive. Now let's talk about Layout Builder. You can use Layout Builder to adjust a layout based on the width constraints provided by its parent widget. This is useful when you need your layout to behave differently depending on how much space is available. With Layout Builder, you can also fine-tune widget behavior inside flexible containers. For example, you might want to change the number of elements displayed in a grid depending on a space available. All right, let's actually see this in an action. All right, back to my project right now. I'm going to define a column here in this case. Let's put it a column with 2 child. Let's change the main axis and cross axis to stretch. Here is my column right now, and if I rotate, well, it's still gonna be a column. But what if I want to change this column in different width size? And that's where we're gonna have a layout builder in this case. What I'm gonna do now, I'm gonna replace it with a layout builder. And my layout builder is going to be a function with context, the build context, and the constraints, the box constraints. Then I will return my column. All right, that's not going to do anything at the moment because we're not using the constraint. But what we can do right now is we can take this column into another widget. Let's call it normal layout or mobile layout. All right, that's great. Now I have my mobile layout. This is going to be my column. Let's now go ahead and actually copy my mobile layout. This time I'm going to change this, let's say, desktop layout. And I will change my column to row. All right, that's good. So I'm going to use now these 2 widgets. Let's say if the constraint max width is going to be more than 600, then we're going to render desktop layout. And if it's not, then it's a mobile layout. All right, fantastic. So let's see if it's actually working. As you can see now, I have a column, and if I rotate, it becomes a row. And voila, this is how you can make responsive. And now you can make your layout even more responsive. For example, let's say in my desktop, I'm actually gonna go and have maybe another row, which in this case gonna have these children. And then I'm gonna have menu here, probably. Or let's say something like that, like a menu 1 and menu 2. Like in my mobile, probably I don't want a menu, but if I go to my desktop, then I'm gonna have a menu and a different rows. Well, this is not pretty as of now, but we can work around it and make it much more better. Modern devices often have unique screen cutouts and system overlays. And Safe Area widget automatically adjusts the layout to avoid these areas. Without Safe Area widget, parts of your UI may be obstructed by notches or status bars, making it difficult for users to interact with certain elements. So far, probably in many of the demos, you have seen that actually I wrapped my scaffold with Safe Area widget. This is what we do to ensure that your content adjusts dynamically, avoiding system overlays. Let me quickly demonstrate that to you. Here is our previous example that we've been working on, and we have now a safe area. Let me actually go ahead and in my mobile, remove the center main axis, and that you see that is coming all the way up. And now I'm going to go back to my page, and before a scaffold, I'm going to remove the safe area. And this time you see that actually the first widget is going behind the notch, and that's going to make it hard to interact with that widget. This is where the safe area is going to help you. You can of course do that yourself with media query and the padding of getting all this information from the device. Well, you have the safe area, so you don't need to do that manually. There's actually one more thing that I want to tell you about safe area, where you have different properties. For example, if I go to safe area, you will see that you will have left, top, right button and maintain button view padding. These are the properties that from time to time, depends on your application, you want to interact with. For example, let's say I don't want to really have the top safe area to be enabled. I can just make it disabled. Or I can say maintain button view padding to true or false, depends on what you want to do. Let's say now I have a button navigation and I don't want to keep the safe area at the bottom too. Let's put it this way, remove both, and you see now the safe area is well maintained. In the previous modules, we have learned about grid. So now let's make the grid responsive by adjusting the number of columns based on the screen widths. We'll use Layout Builder to detect the available space and update the cross-axis count accordingly. You can also fine-tune the layout by customizing the grid's spacing and item aspect ratio. This helps ensure that grid looks polished on different screen sizes. In this version, we are not only adjust the number of columns, but also aspect ratio of the grid items. For larger screens, we set the aspect ratio to 1 to make the items more square. And on smaller screens, we use 0.8 to make them more rectangular. We've also added spacing between the grid item for a cleaner look. All right, let's actually see that in a demo. All right, back to my application. I have actually my grid view from the previous example. This time I'm just loading the Flutter logo. What I'm gonna do here, I'm gonna wrap my grid builder with a layout builder. And in my builder method, I return my grid builder. All right, what we're gonna do here, we're gonna define the number of columns. I'm gonna say if constraints that, let's say, max width is more than 6, let's have maybe 5 column, otherwise 3 column. Then in this case, I'm gonna pass this column to my cross-axis item. I need to make sure that I'm removing the const because this is not anymore a const. All right, so now let's just refresh, see what's happening. That's expected, we're seeing 3, but if I rotate, we're supposed to see 5 right now. Voila, that's fantastic. Now, let's actually work on the aspect ratio. So let's say if my constraint width is going to be desktop, then in this case, I'm just going to have 1. Or if it's actually mobile, maybe more than 1, 1.3. Then I'm going to pass this to child aspect ratio property on my grid delegate. And voila, you see that is becoming more of a rectangle. I can actually increase that. That looks even better right now. So now if I'm going to go and rotate this, it's going to have 5, more of a square. And if I go back, now I'm going to have more of a rectangle and 3 columns. I would like to share with you one tip before we end this video. And that's going to be breaking down your widget as much as possible, because that gives you a lot of flexibility on making your widget more adaptive to the different screen sizes. And I'm going to give you another tip that you can always actually abstract away your responsive manager. For example, you can create a widget that keeps all the different implementation for mobile, tablet, and then in a builder, you can have a layout builder where in the builder method or in the builder function, you can actually take care of the maximum width and return proper widget. For example, you can say whether you want to have a desktop or maybe a tablet or maybe a mobile. Depends on the constraint maximum width that you need. And that's going to take care of your widget. So what I'm going to tell you is that this is going to make it more flexible and you can have more control over that. So in this case, for example, I can come back to my layout builder and I will be able to now use my responsive manager and path different implementation as like this. I hope these tips keeps your code a bit more cleaner. All right, let's talk about some advanced responsiveness techniques in Flutter. So the first one I want to mention is using expanded and flexible widgets. These two widgets are two key widgets for controlling how a space is distributed between child widget in a row and column. We've seen that in the previous module. Then they allow your widget to adjust dynamically based on available space, making it easier to create responsive designs. We already have seen this in module 2. Next is the aspect ratio, which is a widget for maintaining a specific width to height ratio in your layouts. It ensures that your widget always follows a predefined ratio, no matter how the surrounding layout changes. Here, we use the aspect ratio widget to maintain a 16:9 aspect ratio, which is common for video content. No matter the screen size or orientation, this container will always keep this ratio, making it great for media content or other UI elements that needs a consistent shape. So we already have seen also a demo of aspect ratio in the previous video. Let's quickly see another demo of aspect ratio. All right, I'm back to the demo right now, and I have a Flutter logo with a container around it with a border of black. So it's already wrapped with a layout builder. I'm going to get an access to my aspect ratio. So first, I'm going to define my ratio based on maximum width in the constraint. And if it's more than, let's say, 16, it will be 1 or maybe half. Or we can do it also this way. I can keep it as 4.3 and 16.9. Or sorry, this way. So now what I can do is I can go to my container and wrap it with another widget called aspect ratio. And then I can pass my ratio to the aspect ratio. There you go. So now I have it as a 16:9. So that's very good. But what if I just rotate it, which is going to be more than 600 in maximum width? There you go. And now it keeps 4.3. All right, that's very good. So now we're achieving what we were expecting. In Flutter, animations are a core feature, and the framework provides multiple ways to create them. Animations are more than just visual effects. They can make your app feel more responsive and intuitive. By adding subtle movements and transitions, you guide users' attention, improve interaction, feedback, and create a more dynamic user experience. For example, buttons that animate when tapped provide feedback, letting the user know their action was registered. Animations make interfaces feel alive and engaging. You can use various animation in your app, including transition, loading animations, and hover effects. Transition help users understand changes in the app, such as moving from one screen to another. Loading animations indicates that a process is ongoing, keeping users informed. Hover effects provide immediate feedback when users interact with elements. You can implement these animations in Flutter in two different ways, implicit and explicit. Implicit animations are simple, high-level animations that handle the animation logic for you, while explicit animations give you more control but require a bit more setup. For example, when you want to do more logic for animation and you need control over it, that's where you need to use explicit. Both of these types of animations have their use cases depending on complexity of the animation you need. Let's now see both of these animations in action in the next videos. First, let's talk about implicit animations. Implicit animations are controlled by the widget that is implemented it, and there are several built-in implicit animations that you can use from Flutter. Notice most of these animations typically starts with animated and the name of the non-animated widget. For example, animated align, animated opacity, animated padding, and more. The implicit animations typically are extended from implicitly animated widget. Implicit animations also allow you to control changes to the rate of an animation that occurs during the set duration. To define this change in rate, set the value of the curve parameter to a curve. Well, an animation curve is a mathematical formula to interpolate values over time. Always refer to curves class in Flutter documentation to learn more about it. Okay, let's actually now see this in action. All right, here is a simple example. I have a container with a fixed width and height, and I just want to change the color plus maybe the other information on this container. So I'm going to convert my stateless widget to a stateful, and I will define my width, height, and initial state. Make sure my variables are var because I want to change them. Then I will pass this variable to my container. And I will make sure that the width and height actually are double. That's good. So now I'm going to do, as soon as I click on the floating button, I want to change this state just to a random number at a random color. There we go. So I can actually make them random. Let me just remove them. Then I use random. Then I define a random width, a random height, and maybe a random color. All right, there is an error here. It's just because I need to make sure that my type for color is also correct. And there we go. And this time, when I click on the floating button, I get different height, size, and different color. Well, I can make these colors a bit more exciting if I just do as color from RGBO. And then for each of them, I can pass a random number. There we go. So this time I would receive a different color. As you can see right now, it is changing, but not animated. So I can simply come back to my container and then just replace this with animated container. When I change that, there will be a required parameters, and that's going to be a duration. And I'm going to pass a duration to this as, let's say, 1 second. It will be a little bit slow, but that should be okay. And this time, I'm just going to hit the button, and you can see now without me doing anything, it's automatically animated. And you can actually add different parameters from even decoration to this container. Let's quickly do that. For example, you can add the box decoration and border radius in this case. And what if we change the border radius also here with a random number? Now you can repeat this with other widget as well. For example, opacity. So instead of opacity, I'm going to use animated opacity. And I'm just going to make sure that I'm passing a random next double opacity and a duration of, let's say, 1 second. So let's put my animated container also here. And now this time, there you go. Even the opacity is animated. So if I actually change my animated container to container, you see that now the opacity is also animated. There's one more thing that we can do here is that whenever you have this, you can also change the curve. I'm going to do the animated container again. And this time, I'm going to pass different curve here. So for example, now we have fast out, slow in. Let's see how it looks like. There we go. I can change it to many other options that I have. So let's say I want to do an elastic in out. That's it. All right. So let's try one more of this. Let's say I want to do the fast linear to slow ease in. I don't know how it's going to look like, but we can try it out. There you go. You can always change these curves to play around. All right, but what if we want to animate something and we cannot find any implicit animated widget for that? Well, in this case, you can use Tween Animation Builder. Well, let's see how we can do that. So I'm going to go and change my stateless widget, in this case, to stateful. And here is just an elevated button, which I want to change the width. Let's say, in this case, my width is going to be, let's say, 100. And I will pass that to my size, minimum size. Then when I press that, I want to change that to 300. As simple as that. But when I do that, there's no animation. So what I want to do here, I want to go ahead and wrap my elevated button with another widget. And I will use Tween Animation Builder. First, just like other animation, I can actually change the curve. Let's say I want to do it with elastic inside out. Then you have a tween property where you need to pass a tween, where it starts with a begin and an end. So there's either a tween that you can use, or you can explicitly use if, for example, you just need a tween size, where you can pass more information. For example, you can pass all the width and height. Next, you can pass your duration. And then you can define your child. You already have this child, but this is actually going to be our builder. The builder is going to return the elevated widget button. And my child is going to be actually the text. All right, let's test it out right now. All right, one thing you need to notice is that the builder gonna have 3 different properties where it starts from context to the tween that you are defining. So in this case, it's gonna be a size and the child. You can always have different tweens. You can have colors, opacity, and so on. It always starts from a begin to an end. So that's what you need to keep in mind. In this case, now I can pass the size instead of the size that I just defined. And one more optimization I can do is that I can pass the child to this builder. I can even change my child dynamically. All right, so that's good. Now I'm changing the size to 300. Let's see what's gonna happen. I'm gonna refresh, click, and there you go. Let's do that again. One more time. Perfect. So we have now another animation with tween. Let's now talk about explicit animations. In Flutter, typically explicit animations can be controlled by Animation Controller or Animated Builder. Before you start to implement your own custom explicit controller for animation, consider that there are many built-in explicit animations widget that you can leverage in your application without actually going and customizing what you need. First, look for one of these animations and see if you can find what you want, which perhaps you can find one of them. The animation controller is responsible for controlling the timing of the animation. The animation controller needs a duration and also a vsync property. Providing vsync is important as it reduces the load on the CPU by ensuring that animations are only active when necessary, such as when the screen is visible. You may ask then, how can you provide vsync? That's simple. The single ticker provider state mixin is necessary to provide a vsync for the animation controller. Once controller is set, then you can start the animation using the forward method of the animation controller. You can also use reverse to run the animation backward or repeat to loop the animation. A tween defines the range of values to animate between, for example, size, color, opacity. You also need an animation object to apply the tween to the controller. In this example, we use a tween that animates the size between 100 and 200 over 2 seconds. Finally, Animated Builder is a widget that listens to the changes in the animation and automatically rebuilds the widget tree when the animation processes. 2 tips before we go to the demo. First, to avoid memory leaks, always dispose of the animation controller in the dispose method when the widget is removed from the tree. And by default, animations run linearly. You can add curves to create more natural motions, such as ease in, ease out, effects, and more. All right, let's see now all in action in a demo. Here is my Flutter logo, and I want to add a couple of animation to that. For example, I want to rotate this logo. So I can wrap my widget with an explicit animation which ends with transition. So if I just look for transition, I will find a bunch of implicit animations. For example, fade, size, align, scale, slides, and I can also find rotation. All right. I need to now go ahead and change a few things. First, I need to pass a turns because I want to rotate that, right? And if I look at the property, it says rotate except an animations double. All right, so there's a few things we need to do now. First thing first, we need to convert our stateless to stateful. Because I'm going to use an implicit animation, I need to actually use ticker provider state mixin. Then I'm going to define my controller, which is going to be an animation controller. I will make sure that my vsync gets this, and then I will define the duration. All right, next, Now I have the controller. I need to define the animation. What kind of animation I want? Let's do that. I'm going to do an animation, a curved animation, which in this case, the parent is going to use the controller that I'm passing and the curve elastics, as you can see. Here is going to be my animation. All right, sounds good. So now I defined my animation. I can pass it to turn and make sure you're removing the const because this is not going to be a const anymore. But if I refresh, that won't work. Because now you have the controller. You control the animation. You can say what you want to do. For example, you want to repeat the rotation transition. So therefore, here on the controller, you can actually call repeat and maybe also pass the reverse to true. And then this time, as you can see, this is going to start working. And every 2 seconds, you're going to get a repeat on the rotation transition. How about now changing this to maybe a size transition? Then in this case, the property for animation is going to change and you need a size factor. So I'm not going to change my animation. I'm going to still use the curve animation that I defined. Just going to pass that to the size factor. And as you can see now, this is going to change the size from 0 to the size that is there. All right, maybe I can do one more thing. Maybe I can actually just say forward to just happen it once. But if you want to repeat it, you can always return back to the repeat. Let's actually do one more animation here, maybe fade. So we need another property right now, and that's going to be opacity. So I'm just going to pass again animation. There you go. You have now a repeated opacity every 2 seconds. What if I now go change the duration to 1? So it's going to be a little bit faster. And what if I change my curve to a bounce in? Or maybe ease out. There you go. But what if you want to do more general type of animation or something that does not have explicit widget built in? Where here is where you can actually use animated builder. In this case, you need to pass the animation to animated builder and make sure you're using the builder to return what you want. For example, in my builder, I can actually use transform.rotate, and on my animation, I get the value based on the animation time that is coming and rotate this logo. Let's change actually the curves maybe to linear. And this is going to be a little bit more interesting. Now let's change it to another one. And voila. Now you know how to use the animated builder even if you don't have any explicit built-in widget. All right, this is fantastic. But one more tip before we end this session. Always remember, this controller is a listener. So you need to dispose this in the widget dispose so that make sure you're not leaking any memories. The hero animation is used to shared element transition between screens. The widget that you want to animate between screens is usually wrapped with a hero widget, and Flutter automatically handles the animation when navigating between routes. So typically, you're going to have several pages, and in your first page that you are going to transition from, you're going to wrap your widget with hero widget and add a unique tag, which is going to be a unique identifier. In the second page, or in the page that you are going to transition to, then you need to do the same and also add the same tag. Then Flutter will handle the rest for you. All right, let's see it in action. Here is my simple application. The first thing I want to do, I want to actually wrap my scaffold here into a different widget, and I will just call it page. So I will do the same with page 2. Well, this time I'm going to remove the center widget, and I will make sure that I will have a bigger size. And this is going to be for page 2. All right, that's good. Now in my material app, I'm just going to define two routes, page 1 and page 2. So I also need to define the initial route, which is going to be, in this case, my page 1. Also in my page 1, I'm going to add a floating action button with an icon of navigating to the next page. And in onPressed callback, I'm just going to push to the second page. So right now, if I just go to the next page and come back, there is no animation. But what we're going to do right now, we're going to go and wrap the Flutter logo with hero widget and give it a tag. We're going to repeat the same in the second page. All right, that's good. Let's refresh and go to the second page. There you go. On the second page, let's actually add an app bar so that we can easily navigate back and forth. Let's try it again. There you go. It's animating as it's expected. All right, now let's talk about staggered animation. Staggered animations involve running several animations with different start times or overlapping durations. This is achieved using the interval class in Flutter, which allows you to define a portion of total animation duration where each animation should occur. You can control each of animation's timing within the overall duration to create the stacker effect. Well, I know what you think right now. We need to see it in action in a demo. All right, here is my demo. A typical example of a staggered animation is a list view that you want to animate each item with some kind of delay coming after each other. All right, so what we're going to do right now, we have a list builder that is going to build the list of entries that is generated by 16. So this is a dynamic list, imagine. The first thing we're going to do here is we're going to change the stateless widget to stateful. And then make sure you are using the single ticker provider state mix in to get access to the vsync. Define your controller and define a list of animations. Why? Because each item on this list now needs to have a specific animation with some kind of interval, which starts from a beginning to the end. Okay, let's move on to see what we can do right now next. So I'm going to define my initial state, but before doing that, let's just also define a dispose method where it's going to dispose my controller. So what I'm going to do in this initial state is that first thing first, calling a super state, and then I'm going to define my controller. So in this case, I'm just going to pass a duration of 4 seconds and a vsync of this. So next, I want to make sure that I'm going to call the controller forward in order to make the animation running. So between the time that I start, here is the forward, and the time that I'm actually defining the controller, I need to iterate over my entries and define animation for each item. Okay, let's see what do we need first. I want to define an animations, right? And just like what others animation we've done, we need, let's say, a curved animation. But because we're going to have it staggered this time, we need to have an interval which is going to have a begin and an end. Okay, so we need to define the beginning and the end of this interval. So let's start by defining that then. So we're going to define a beginning by an index of this array divided by the entire array. And to the end, let's just get the begin and then plus with some numbers. Just want to have different numbers for each for the duration of ending of these slides. And at the end, we're going to add this animation to the list of animations that we just defined. Okay, so what we've done is that we iterate over each item. We define the begin and an end for it, and then we created an animation. And then using interval, we created an animation and added to the list. Now we need to go back to our implementation. Let's go in item builder. I'm going to wrap my container with an animated builder. So what do I need? I need an animation. And this animation is going to be based on a list that we just created. And then I also need a builder, which in this case, I'm going to return an opacity on top of my widget, which is going to be the container. All right, so next is that the opacity is going to get the animation value. All right, so far so good. Now I'm going to refresh. All right, we are actually now getting an error. This is deliberate. I wanted to see that this is an error. There is an error interval because the value is not what it's supposed to be. Let's go back here. We just defined this, but this needs to be exactly a number between 0 and 1. So you have two options. Either you can define some kind of value. For example, you divide it by 4, both of them. And in this case, if you refresh, you get now a perfect animation. Or what you can do, you can use clamp and define the lower limit, which is going to be 0, 0, and an upper limit, which is going to be 1, same for end. And now this time, perfect, you get the animation. It's up to you what you want to do. You can play around with all of these values. But let's go back here, or this is a staggered animation. So it's coming with an opacity, but what if you want to do a transform from left to right? That's where you can wrap your child widget with a transform translate. So here is another case. So I'm actually going to, let's put it this way. And in this case, I need to define my offset from X and Y. So that's totally up to me which kind of value I want to pass here. But of course, mixing that with animation value that you are receiving is going to make it more nice. Let's say now I'm defining the Y, refreshing. Now this is coming with opacity and also transform. I'm going to actually change Y with X. And then this is going to be left to right this time. And this is much nicer. So definitely playing around with these values will have more effect. And of course, if you want to make it faster, you can go ahead and maybe limit the duration of the controller. And that's going to be even faster. All right, perfect. That's the staggered animation and happy coding. The last thing I want to talk about in the animation module is the page transition. Flutter defines default page transition based on platform of choice. Let's see how you can change that in a demo. All right, here is our demo from the previous hero animation widget. So I can go to the next page and I can come back. And because I'm using iPhone in this case, so the default behavior of page transition is a slide. And on Android, it would be fade. But how can you change this? So first thing first, you need to do is you need to remove the routes if you are using the navigation 1 in this case. And now you need to replace it with on generate route. What you need to do is you need to check for each page name and return the page. All right, let's do that. Because I'm going to actually have similar animation for all pages, I'm going to create a function that is going to wrap my pages. So in this case, I will make all animations similar on all pages. Let's actually create a custom route. This time, I'm going to actually return a page route builder. A page route builder would have two properties that is interesting for me. Let's show you. So the first one is going to be page builder, and the second one is going to be transitions builder. In the page builder, what I'm going to do, I'm going to just return the page. And for transition builder, let's say I'm going to return fade transition. That's it. So now I'm going to refresh. Okay, I see that I made a mistake. My function name wasn't correct. I corrected. Now if I go back this time, I'll see this, there is no slide, it's actually a fade. Oh, this is fade, very simple. But what if I want to customize my animation? Let's say I want to actually open the page and sliding from bottom to top. So I'm going to wrap my child again with the slide transition. And I need to pass a position, which is going to be an animation. And I'm going to use actually tween in this case. Let's do that. So my tween needs a begin, which I will define it as 0 offset for X and for Y 1. And to end, let's call it 0, just everywhere 0. All right, sounds good. I'm going to chain it with maybe an animation curve and then animate it with the animation that I'm receiving from the callback. That's all good. All right, just going to refresh. All right, let's go. There you go. Both fade and from bottom to top is happening. Sounds good? And this is how you can change your page transition in Flutter. And that's the end of this module. And that's a wrap up. Thank you for your time, and I hope you enjoyed this course as much as I did. Remember, this was just the beginning, and continue to do 3 things for sure. Practice, practice, practice. Happy coding!